All right, so with this question, they are asking you to take the derivative of this integral. So because we're trying to find y prime, we're really looking at taking the derivative of an integral. And we know that when we're taking the derivative of an integral, they're going to cancel each other out by the fundamental theorem. So when you see this differentiation of an integral, that tells you to use the fundamental theorem. And it tells you that everything's going to cancel out except for this integrand. And what you'll do is you'll be plugging in this x to the 6 in for the variable of integration. So you are going to have that y prime is equal to cosine square root, you plug in the x to the 6 in for t, and then we have to multiply by the derivative of the upper bound. And we're just taking the derivative of x to the 6. So that's going to be 6x to the 5th. Now, one thing that you want to do is you want to move the 6x to the 5th to the front. And then this cosine, you could leave it like this, but it's not simplified. So remember that the square root of x to the 6, that is really the same thing as x to the 6 raised to the 1/2, which would give you, when you multiply straight across here, the fraction times the 1 or times the 6 would give you x to the 3rd. So this is going to simplify out as cosine x to the 3rd, and that's by your radical properties, the fact that the x to the 6 could also be written as x to the 6, and that radical would be your 1/2 power. Okay, so this would be your final answer.